Welcome to the deep dive. Today we're looking at something, well, frankly, quite concerning. It's where AI tech, which is evolving so fast, meets the constant world of cyber threats.
Yeah, it's a really critical area right now.
We're basically uncovering this clever, pretty dangerous trap that relies on something we all use every day, trust. And we're focusing on one specific case, a fake ChatGPT app.
In this case, it really holds a key lesson, doesn't it? It shows how attackers are now twisting genuine innovation, even open source projects, for their own ends.
Right.
So we're not just talking about what went down, but really digging into the how and the why, and why it's such a big challenge now.
Exactly. And the implications are pretty huge when you think about it. So our mission today is to unpack all the details of this digital deception using the sources we've looked at. We want you to really get the mechanics behind these modern threats.
Okay, let's start with the bait, because honestly, it was brilliant in a devious way. Everyone's using tools like ChatGPT, right?
Absolutely, they're everywhere. And the thought of having a neat little desktop app for it, well, that's just convenient. It sounds great.
It does. It feels natural.
Which makes it the perfect setup for exploitation, doesn't it? Almost too easy. I remember years back almost falling for something similar with a supposed video editor.
It really is the perfect setup, and that's exactly what happened here. Microsoft raised the alarm about a new malware campaign. What the attackers did was hide their malicious code inside a fake version of an open source ChatGPT Desktop app.
Ah, okay, so not the official thing people might expect.
No, and this is crucial. The real ChatGPT Desktop project on GitHub, that's perfectly safe, it's legitimate. The danger came from these imposters that just used its name and popularity.
Okay, so the real one's fine. But how did these fake, dangerous ones get out there? How did they reach people? Was it just like dodgy download sites?
It really highlights how they play on trust. Basically, the threat actors cloned the legitimate GitHub repository.
So a complete copy.
A complete copy. Then they sneakily inserted their hidden malware code into that copy, and then they distributed these altered versions through various unofficial channels.
Okay, so not GitHub itself, but other places online.
Exactly. Maybe forums, maybe third-party download sites, maybe even targeted links. So if you happen to download from one of those compromised places, you were unknowingly running a backdoor on your own system.
Wow. It's the classic Trojan horse then. You think you're getting something useful.
And bam, it's carrying something malicious right inside.
That's clever and simple in a way. It means even if you think you're grabbing something from a known open source project, you've got to be double, even triple checking the source URL now more than ever.
You really do. Is this cloning and unofficial distribution becoming more common, especially with all these AI projects popping up?
It seems to be. The speed and the kind of decentralized nature of open source development, particularly in AI, well, it creates opportunities for this kind of deception. Users just need to be more critical, even if it looks familiar. Okay, so we see how the trap was set. But what about the payload? What actually gets unleashed? Let's dig into this malware PipeMagic. What makes it so dangerous?
Right, PipeMagic. It's fascinating from a technical standpoint, actually. Its design is quite sophisticated, unlike older malware that might bundle everything together.
Like one big file.
Exactly. PipeMagic uses what's called a modular architecture, so it doesn't carry all its functions at once. Instead, it dynamically loads different modules. Think of them as plugins when it needs them.
Okay, so it pulls in tools as required.
Precisely. One module for talking back to the attackers, another for executing specific commands, maybe another for stealing certain data. This makes it incredibly flexible.
And probably harder to detect, I imagine.
Much harder. That's where its stealth comes in. It uses encrypted named pipes. Imagine like a secret, secure tunnel inside your computer for data to flow. And it relies heavily on in-memory operations, meaning it tries to run directly in your computer's RAM, its temporary memory, rather than writing files to your hard drive.
Which means less evidence left behind.
Exactly. Traditional antivirus often looks for suspicious files on the disk. This approach tries to avoid that. Internally, it's also really organized. It uses linked lists, sort of like digital to-do lists, to manage everything.
Like queues for tasks.
Yeah. Specific queues for modules waiting to be loaded, for network communications, for payloads it needs to run. This structure lets the attackers easily swap out or update parts of the malware without needing to reinstall the whole thing. Super efficient for them.
It sounds disturbingly well built, almost like legitimate software architecture, but, for evil.
You could say that.
Yeah.
The level of design points to experienced
Well,
developers.
this isn't just some script kiddie's work, this modularity and stealth. Does it mean our usual defenses are struggling? Especially with AI making new attack methods potentially easier to create.
It definitely poses a challenge. That modularity means security tools can't just look for one single signature or pattern anymore. They have to understand the behavior, the communication.
So it's about behavior detection more than just file scanning.
Increasingly, yes. And you're right, there's a sort of mirroring effect. As legitimate tech like AI becomes more modular and dynamic, the threats are adapting using similar principles. It forces a rethink in how we approach detection and response.
Okay, which brings up the communication part. How does this sophisticated malware phone home to its controllers without setting off alarms? That's often the weak spot, right?
It is often a point of detection, yes. And PipeMagic is clever here too. It actively avoids making direct, easily spotted connections to a command and control or C2 server.
So no obvious IP addresses it keeps contacting.
Not in the traditional way. Instead, it loads a specific networking module, and this module sets up WebSocket-style encrypted channels.
WebSockets, like the tech used for real-time updates on websites.
Exactly like that. It creates a persistent two-way communication line, kind of like keeping a phone line open, but it's all encrypted, very hard to eavesdrop on.
And what does it send back through these channels?
All sorts of system information. Things like a unique ID for the infected machine, the bot ID details about the network domain, the process integrity level.
What's that? Process integrity.
It basically tells the attacker how much administrative power the malware is running with on your system. High integrity means more control. It also sends user context, like the username.
And in return, what commands can it receive?
Pretty much anything the attacker wants. Launch ransomware, sure, but also steal system password hashes, list all the running programs, even tell itself to rename its files and delete itself to cover its tracks.
Wow. That adaptability makes it a really persistent threat then.
Extremely. It can morph its function based on the attacker's immediate goals.
Okay, so this isn't random. A tool this sophisticated suggests a coordinated group behind it, which leads to the question, who is behind this campaign?
You're right, it's not amateur hour. Microsoft has pointed the finger at a group they track as Storm 2460.
Storm 2460. And what's their motivation? Money. Espionage.
They're identified primarily as a financially motivated group, so likely after money through things like ransomware or data theft.
And what makes their recent attacks stand out?
Well, what's particularly concerning is how they've combined PipeMagic with something else, a specific zero-day vulnerability.
A 0-day, meaning a flaw nobody knew about yet.
Exactly, a flaw in the Windows Common Log File System, or CLFS. It's tracked as CVE 2025-29824. Because it was unknown, there was no patch available initially.
So they use this 0-day to get in? Or
To escalate privileges. They might get initial access through the fake app, but the 0-day lets them gain higher control within the system, like administrator rights, and then they deploy ransomware. It's a very potent combination.
Okay, that's serious. So where have we seen Storm 2460 active? What kinds of organizations are they hitting?
They've targeted several sectors, including financial services and real estate. And geographically, it's quite widespread. Victims have popped up in the US, Europe, South America, and the Middle East.
So a global operation.
It seems so. And by using 0 days alongside a backdoor as stealthy and modular as PipeMagic, well, Microsoft says Storm 2460 is demonstrating advanced tradecraft.
Advanced tradecraft, meaning they're skilled, sophisticated.
And make life very difficult for incident response teams trying to clean up after an attack. This whole campaign really just hammers home the danger of attackers exploiting that trust we place in things like popular apps or open source projects. They use it as a delivery mechanism right into corporate networks.
Which brings us to the crucial part for everyone listening. What does this actually mean for you? What can people and organizations do to defend against these kinds of attacks, especially when they leverage the very tools like AI that we're excited about?
Well, the good news is Microsoft is aware and has rolled out detection updates for this specific threat in Microsoft Defender. That's a start.
Okay, so update your security software. Standard advice, but critical.
Absolutely. Beyond that, organizations really need to audit their systems, look for any signs of compromise. Patching is huge, especially for known vulnerabilities, and particularly for 0 days like that CLFS flaw once patches are available.
Right, patch promptly.
And Crucially, you need to critically review your sources for third-party software. This is key. It's not enough anymore to just see, oh, it's on GitHub, must be fine.
Because of the cloning issue.
Exactly. You have to verify you're getting it from the actual legitimate project owner, not from some lookalike clone hosted somewhere else. Check the developer, check the repository details. That verification step is vital.
That's a really important takeaway.
Mhm.
Don't just trust the platform. Verify the source on the platform.
Yeah.
This has been, well, eye-opening. It really shows how cyber threats are getting more sophisticated, preying on convenience, preying on trust, especially around exciting new tech like AI.
It really does. And it leaves us with a big question, doesn't it? As we rely more and more on open source software, on rapidly evolving AI tools, how do we balance the incredible benefits of all this innovation with these, well, these subtle but growing risks around digital trust and just the sheer volume of information? What do you think is the most crucial step for staying safe in this landscape?
That is definitely something to think about. A challenging balance. Thank you for joining us for this deep dive today. We hope it's given you some valuable insights. Keep exploring, keep questioning the digital world around you, and please stay safe out there.